Hello everyone, let's solve Max exam Math B question 2 2014, okay? B yeah, B 2014, okay? Question 2, okay? So this question he's telling you about circles and tangent lines. So if you had the drawing ready, like if you had the circles and the tangent lines, things like this, it would be much easier, okay? But he didn't give us this. Now look, I did solve this question already before this video, okay? So I know how the circles are, and I even put them in the software, but I'm not going to draw the circles just as they are in the question. Why? Because I want to show you how to think about it when you are solving the question, because when you are solving this question you don't know the result, but in the end of this video I'm going to let the drawing made that I made in the software. So if in any point in the video you get lost from me drawing and you don't understand the drawing, go to the end of the video and see the how the software draw it, right? Okay, so let's read the question. So you have two planes, you have two circles, C with a radius of 1 and the second circle with radius r, okay? The second circle with radius r. And this is the problem for us to draw, because we don't know if r is bigger than 1 or smaller than 1, but it won't make any problem. We are going to use math, okay? So which intersects on a plane at each of the two intersection points. So they will have two intersection point, right? So I'm going to draw them again better, okay? Just so that we make sense of. So we have two intersection point over here, this point over here and this point over here. Okay, so in these two intersection points you have tangents line to the circle, to each circle. So what does this mean? So you have a tangent line to the first circle and a tangent line to the second circle, and these form 120 degrees, okay? So one second, let's go over here. So look, we have let's draw these circles, okay? So here, let's make it a bit smaller over here and put it over here, okay? So this is our first circle. Now the second one has the radius r, right? So let's put it a bit bigger, okay? So this is what I thought. Now it could be bigger or smaller, right? We don't know. All we know is that we have two intersections, okay? So let's say this, for example. So this is our second circle, okay? Now we are going to draw the tangent line, okay? So this is the first tangent line, okay? And now the second tangent line to the second circle over here, okay? Here. Okay, so this is basically what he told us. Now we look, this line over here, this line is tangent to what circle? To this circle over here, okay? So this line is tangent to this circle, and this line over here is tangent to this circle over here, okay? I think this is you can understand this. So look, this line is only cutting the circle in one place in this circle, okay? So it is tangent to that circle, okay? So, and this angle is the angle of 120 degrees, okay? So now let's go to the other app where I can write better, so that we can use this drawing, okay? One sec. I have over here the number of the question and the drawing that we just did. Now look, in this drawing over here, I need to note, it's like the center, it seems like it makes sense over here, and this is the radius, right? This is the radius. Okay, now look, this is what? This is 120 degrees, but this is the radius, the yellow one, and this is, one second, and this is the tangent line to the circle, right? So this should make 90 degrees over here, right? Because this is a line tangent to the circle and the radius, so it is 90 degrees. But this doesn't make any sense. Why? Because this is 120 degrees, so this is 120 degrees and this is 19. So is why is it wrong? Well, because the center is not here. Because you need to remember that this drawing, we are making it. It's not the question that gave us this drawing. So the right answer, that the center is a bit over here and our drawing is off. And so if you were in the exam, you could just say like, the center is over here, and continue solving. Okay, it doesn't need to make the drawing is just so that we can see. Okay, but I did another drawing over here. Let me just delete this one over here, and I did another drawing that it seems better, like the center is here and the center is here. Okay, just so that we can understand better. So this is, let's say that this is the center over here. We have, this is the radius. Okay, so remember, from the radius to the tangent line to the line tangent to the circle, it is 90 degrees. All this is 120 degrees. This is 19. So what is this side over here? Well, this is from 90 to 120. This is 30 degrees. Okay, what am I saying right now? This small line over here, this is the radius, right? So this line over here is the radius. Okay, radius. Now the angle between the radius and the line that it is tangent, this line over here, it is tangent to this circumference. This angle should be 90 degrees. Okay, this angle over here is 90 degrees. Now the whole angle over here, this line to this line, is 120 degrees, but this part is 19 and this 90, and this part is 120. So one, let me try to draw it up. So this part over here is 30 degrees. Okay, this part over here is 30 degrees. Okay, this part is 90 degrees. Okay, this part is 90 degrees because it is tangent. Now for the second circle over here, we can do the same thing. Okay, this is, one second, let me try to draw it. This is the radius. Now the radius to the line that it is tangent to the circumference, this line over here that is tangent, not the blue one. The blue one is the radius. Okay, this line over here is the tangent line. You really need to take paper and draw with me. Okay, so this line over here, so this is 90 degrees. Now remember, all this was 20 degrees, was 120 degrees, 120. Okay, so if this part is 90 and all of it was 120, so this part over here is 30 degrees. Okay, now why is this important? Because all of it was what? Was 120 degrees, all of it, right? But now we have this part. Let me do it with another color. This part over here. What is this part? Well, this part, let's call it x. So x plus 30 plus 30 should be 120, right? So 30 plus 30 plus x is equal to 120. So x, this x over here, is 60 degrees. Okay, so this is what I was trying to do all this time, was to find this angle over here. Why? Because now we know everything we need to know to solve this question. Okay, so look, this was our center. This was our center, right? This line that I'm drawing right now is question 1, right? He wanted us to know what is the distance between the first center to the second one, and we know now this angle over here. So I'm going to draw just the triangle. Okay, it might be like this. So this radius over here, the yellow one, is r. He gave us this in the question, r. This angle over here is 60 degrees. And this side over here is 1. It is this radius over here, the blue radius, okay? And the thing that we want is x. Is x now. This side over here, okay? Actually, I think he called it d. I think he called it d in the question, so d, okay? This point over here is the center. This point over here is the center of the second circle. And we can call this point the point of intersection. We can call it a, okay? Now, if you remember the cosine law, the cos law, it tells you that you have a side squared is equal to the side that is opposite to the angle, okay? It's equal to b squared plus c squared minus 2 bc multiplied by cos of the angle. So d squared, d is this one over here, d squared is equal to what? To b squared. B squared is 1 plus r squared. C is this and b is this, okay? The cosine law. If you don't know this, search cosine law, okay? Something like this. So minus 2 multiplied by b. B is 1 and c is r, multiplied by cosine of theta. Theta is 60 degrees. So cosine of 60 degrees is equal to a half, okay? So multiplied by a half. So we have that d squared is equal to 1 plus r squared minus, now 2 divided by 2 is 1, 1 multiplied by r is r, okay? So we'll have that d squared is equal to r squared minus r plus 1, okay? So d is equal to the square root of r squared minus r plus 1, okay? So this is our first answer, okay? Express the distance d, express the distance d between the center of C and CR. So all we did until now was understand the way that we need to draw it. We drew it, and then we found the angle so that we can have a nice triangle so that we can find D, okay? So this is what we did. Now the second question, calculate the value of R at which D in the attains the minimum. So what does this mean for us? Now look, this is D, right? This is the D. He wants R such as we have the D minimum possible. So if we want D minimum possible, well, D is equal to this, right? Now the square root is not doing anything right now. So look, if you had inside the square root like 4, okay, but it would be 2, right? But if you had 3, then it will be smaller than 2. It will be 1 point something. So the smaller the thing we have inside, the smaller this part over here, the part in this part over here, the smaller this part over here is, the smaller the yellow part is, the smaller D is, okay? So r squared minus r plus 1. We wanted the smaller possible. Now you need to remember that this is a parabola, so it is something like this, and it is a happy one because it's positive right here, so it has a minimum point. So perfect, right? This minimum point Now we call it x of the vertex, right? So x of the vertex, remember the formula, it was minus b divided by 2a, right? So minus b minus minus 1, right? Because b is over here, it is minus 1 divided by 2a. Well, a is 1, so it is 2. So this is the value of our minimum, okay? Now you can do it in another way. I think this is the best way to do it. Like, it doesn't take too much of you, but you can do it with calculus if you want to. But just remember, so for d, one sec, for d minimum, we have that r is equal to a half. Why? Because we took the lowest value for this r over here, doing the x of the vertex. But you can do that. Remember, if you want the minimum, you take the first derivative and say it is equal to 0. Okay? Now, just for us to review calculus, because Max does require calculus, so let's just have this over here. So it will give us a half too, okay? So what is the comma? Okay, the derivative. So it will be half multiplied by the yellow part, right? The yellow part, which is r squared minus r plus 1 to the minus half, right? Like, what am I doing over here? Look, I'm going to call the yellow part u, okay? So look, we are deriving u, okay? So if d was equal to, if d was equal to the square root of u, okay? Of u is equal to this, okay? So this is u, okay? What is the derivative of d? It would be d comma is equal to a half multiplied by u, and now it was to the 1/2 minus 1, right? Because it is the derivative, multiplied by u comma the derivative of u. So d comma is equal to 1/2. Now 1/2 minus 1 is minus 1/2, so it would be dividing downwards, okay? And what is u? U was r squared minus r plus 1 to the half. Now u comma, what is the derivative of u? It is 2r minus 1, okay? And now we say that this derivative is equal to 0, so all of this will go to the other side multiplying, which equals 0, and 2r minus 1 is equals 0, so r equals 1/2, okay? So I just wanted to put this extra part over here, how we can do it with a derivative, but as it is a quadratic function, we were able to do it without derivative, okay? By doing the x of the vertex, okay? So we did find the second one was r equals a half, okay? So in case 2, express the area of the intersection of C and CR in terms of the constant P. So what does he want now? Look, this was our circle, right? So our circles over here. Let's take all of this out. So the intersection that he's talking about is this part over here, okay? Now this is the area that he wants. When now we know now the radius, okay? Now let's just here. So the yellow radius now that was r is going to value now a half, okay? The value that we did just find it is going to value a half. Let me just 1 second over here. Let me just. So how do we go on solving this? So look, we have this center over here, It was blue, right? One sec. We have the center of this circle over here. Over here. And over here. So look. And now for the second circle, it was something like this, right? So I'm going this line over here. I'm going to draw a line of I'm trying here, this line over here. So look, for the first part over here, we have this segment. This segment is like this, okay? So we are going to find the area of this segment of a circle, okay? And then we are going to subtract the area of this triangle over here. This triangle, this one over here, okay? So we have a segment and a triangle. Now look, the part that we want, I'm going to put it in this color over here, okay? So look, now this part over here, it is, we get it from this segment, right? It is over here minus the area of the triangle that I'm going to put in red over here, okay? So this area of the triangle over here, okay? Okay, now for the second section over here, we have this part over here, okay? Which is this section of the circle, this section of the circle with the blue parts minus this triangle over here, okay? So this is what I need you to focus on. So look, I put the information that we got until now over here, the information for D, and so the expression for 1, like this one goes over here, this one goes over here. Now we need to find 3, right? And now I added another picture that I did it in my notebook, and I put the answer always in the Google Drive that I have, okay? So I think I have a link in the description. So look, the area in red is the thing we want, and now for this D over here, how did I find this D over here? Look, just plug in the value of R over here. So look, D is equal to what? R squared, 1/2 squared, minus R plus 1, right? I just put the value of R over here. So what is D? Well, D is going to be equal to the square root of 1 divided by 4 minus 1/2 plus 1. This is equal to a square root of 3 divided by 2, okay? So this came from here. And what was D? D is the distance from the two centers, right? So this distance over here, okay? Now what am I going to do? We are going to find this area over here, and then we are going to subtract the area of this triangle, and I'm going to show you a new formula to calculate the I don't think it's not like new, but to calculate the area of triangle, you don't need to always have a half of the base multiplied by h. There is another formula, which is half of the, which is going to be using these angles over here. It is easy to prove it, okay? So half of AB multiplied by sine of the angle. being AB the sides of this of the angle. Okay, so look, what does this mean? If you had a triangle like this, this is theta, this is AB. So the area of this triangle, is this. Okay, so I'll see if this video is not too long. In the end, I'm going to prove this. Okay, the area of a triangle. Okay, but first let's find the area of the circular part. Okay, so look, the area of this part over here. Okay, this part over here. Now look, if you wanted the area of the whole circle, what would it be? And here this my circles, it was this was the circle in the right side, and this was the circle on the left side. Okay, it doesn't matter if you want to put here 1 and here a half, it wouldn't change much. Okay, so it's just that when I drew it, I did it this way. Okay, so no problem. Okay, now what is the area of this whole circle? It would be p r squared, right? But r is equal to 1, so 1 squared, so it would be p. When is it p? When we are taking the whole circle, when we are taking 36 degrees of it, or 2 pi of it. Okay, we are going to use 2 pi because it's easier to. So when we are taking, so this is area and this is the angle. Okay, that we are taking. Now we don't know the angle and we don't know the area when we have this angle over here, 2 beta. So we need to find beta, right? So how can we find this beta over here? Well, look, we can use the sine law. What do I mean by this? Look, do you remember that if you have an angle, sine of an angle divided by the side that it's opposite to it is equal to the sine of an angle divided by the side of the opposite side of it. What does this mean? Well, you have over here 60 degrees and this is the side that it's opposite, so you'll have that sine of 60 degrees divided by the opposite side, square root of 3 divided by 2, square root of 3 divided by 2 must be equal to sine of 2 beta sine of 1 beta. Just let's take just 1 beta, this beta and this half over here, so it is equal to sine of a beta divided by this side over here, because this side is the opposite to this one, and this angle has an opposite this side over here. So this is called the sine law, right? We already used the cosine law and now we are using the sine law. Okay, so sine of beta divided by a half. Now sine of 60 degrees is equal to square root of t divided by 2, so this is actually 1. Okay, so we are going to have that sine of beta is equal to 1/2. Now if sine of beta is equal to 1/2, then beta is equal to 30 degrees. Okay, so this is beta. So if beta is equal to 30 degrees, 2 beta is equal to 60 degrees. Okay, so in place of 2 beta we can put 60 degrees. Now 60 degrees is pi divided by 3. Okay, this is 60 degrees. Okay, the same thing. Now we can find the area of this part over here. So x is equal to pi divided by 3 multiplied by pi, this multiplied by this divided by this, right? Divided by 2 pi. So our x is equal to pi divided by 6. Now we need to save this. Okay, so we found the whole area, the area of all this. What we are going to do now is subtract the area of this triangle over here. Okay, so let me just take this part over here off. Now we are going to take the area of this triangle over here. Now remember, this was 2 beta. This angle over here is 2 beta, and this is 1, and this is 1. So remember, it is half of AB sine of the angle if we want the area of a triangle. So it is half of A, which is 1, multiplied by 1 multiplied by sine of 2 beta. Now 2 beta is what? Is 2 beta is 60 degrees. It's pi divided by 3. So sine sine of 2 beta is square root of 3 divided by 2. Okay, so just remember, this area over here was of the whole thing. Okay, and now what we did find is the area of just the triangular part. Okay, which is this, multiplying, so it would be square root of 3 divided by 4. Okay, over here 2 multiplied by 2 is 4. So now look, what part do we want from it? We want only this part over here. We want this part over here, right? So we need to subtract them. We need only this part over here. So we need to, so our part of the area is what it is. It was the whole thing, pi divided by 6 minus the square root of 3 divided by 4. Okay, but it's not over, because it's not over. Why? Because now we found what? We found this part over here. Now we are going to do the same thing to find this part over here. Okay, and here comes the trick part from the drawing, because the drawing is really not accurate. So look, let's find the value of alpha. Okay, how are we going to find the value of alpha? By using the sine law again. Okay, so how can we do this? 1 second. So look, sine of alpha divided by what? By the opposite. Opposite of alpha is 1. Okay, divided by 1 is equal to what? To sine of 60 degrees, this 60 degrees, divided by what? This side over here, the opposite side, square root of 3 divided by 2. Okay, so remember, sine of 60 degree is square root of 3 divided by 2. So this is going to be 1, multiplied by 1 is 1. So sine of alpha is equal to 1. So alpha is actually 90 degrees. Okay, so very complicated question, right? This is the second time we are using the sine law. Okay, so alpha is equal to 90 degrees. So what does this mean? This means that 2 alpha is what? Is 180 degrees. 180 degrees. Now remember, our formula to find the area of triangle, I'm going to prove it in the end of the video in 1 second. So it was 1/2 of AB sine of the angle, but our angle now is 2 alpha, so it is sine of 2 alpha, but sine of 2 alpha is 180 degrees. Sine of 180 degrees is equal to 0. What does this mean? That this triangle has an area 0? Well, yes, because the actual drawing is something like this. Okay, so it is cutting like this. Okay, we have I'm going, look, this part over here, this part over here, this part over here is the part that we just found, okay? This part over here is the part that we just found in the drawing. It is this part over here, okay? But there is no triangle. This is what he's telling us. He's telling us that it is all in the intersection. So we don't need to calculate another triangle, because calculating the second triangle is 0. So what we have left is half the second circle, okay? Half the second circle that we need to find. And I think in the end of the video everything will connect better, okay? So look, as this triangle does not exist because it is 180 degrees, so it is cutting actually like this circle, okay? Like this. This part over here is this part over here, and now we need to find this part over here. This part is half of the area of the small circle. We have a small circle with the radius of a half, so the whole area of it would be p multiplied by r squared, right? But now we only want half of it, so it's going to be p multiplied by divided by, now 2 squared is 4, multiplied by 2 is 8. And this is the end of our question, okay? So here we need to sum p divided by 8. Now doing this sum, we'll have that the area is 7p divided by 24 minus square root of 3, right? Square root of 3 divided by 4. Here we have 8 and 6 is 24, and then we're going to have that 3 plus 4 pi, okay? So this is why 7 pi divided by 24. Now I'm going to show you in the program how the circles are. But let's prove that the area of a triangle is, you can find by half AB sine of the angle between AB. So look, imagine that we had this triangle over here, okay? And so this over here is H, and this is A, this is B, and this is the angle, okay? The angle that we have. Now look, the area that we know is half of B multiplied by H, right? Half of B multiplied by H, the base multiplied by the height. Now remember that we can express sine of the angle that we have by the opposite divided by the hypotenuse, right? So divided by A. So H is actually equal to A multiplied by sine of the angle, okay? And now we can put this value over here, okay? So half of B multiplied by H, but H is A sine of the angle. So this is like very useful to remember, and it's very, very easy to deduce, okay? So over here we have the first circle. I put its center in the middle, in the 0, 0. This is the circle with radius 1, okay? So you can see its equation over here, okay? So, and then we have the second circle's equation, okay? So where, 1 second, let me find, oh, over here, okay? So you can see that the only thing that changed it is that the x, it's now, I put it in the x square root of 3 divided by 2 to the right, right? In the y it's still in the 0 axis. So why did I do this? Because remember, this square root of 3 divided by 2 was the value of d. It was the distance between the two circles, between the two centers, okay? So I moved the center of the second circle, the value of d, okay? And this 1 divided by 4, why is it 1 divided by 4? Because 1/2 squared is 1 divided by 4. So this is the radius of the second circle that we found, that was 1/2 squared, okay? Now over here I have the equations of the tangent lines. I can do a whole video about just finding tangent lines to the circles, okay? So you can see that this black line is the tangent line to the blue circle, the red line is the tangent line to the orange circle, this is the point of intersection over here, and here we have the line that goes through the center of this circle. Look, just as I told you, this is the B is the center of the circle, of the blue circle. Okay, so B is the center of the blue circle. You see that they are in the same line over here, and A is the center of the orange circle. Let me see if there's something. So let me see if I can write over here. So look, what was the area that he wanted? He wanted this area over here, which was half of the small circle, half of the circle that has a radius of a half. Okay, and what else did he want? Now, for the big circle, we had this radius over here, right? And then we wanted this part over here. So how did we find this part? Let me just delete. How did we find this part? We found the whole area of all this, and then we subtracted the area of this triangle over here. Okay, so this is what we did. Okay, so, and this is the part, like, imagine if you had this drawing over here ready, right? It would be much easier, you would solve it much faster. You can see what he wanted. Okay, so this is it. I hope you understand. Here, if you want, try to put them in a program. You can go in Desmos or GeoGebra. I'm here in GeoGebra, and you can put these things and play with them.